Hello dear students. So in the last class we have seen the necessary condition for the Pfaffian differential equation x dot dr to be integrable. So today we will see the sufficient condition for integrability, and while proving the sufficient condition we will see the theorem 1 and 2 which we have already proved. So the first theorem was, so if u is equal to u of xy and v equal to v of xy, and if there is a functional relation connecting u and v of the form f of uv equal to 0, which is independent of x and y. So this happens if and only if determinant ux uy vx vy equal to 0. That was the first theorem. And again the second theorem was, if x dot curl x is equal to 0, that implies mu x dot curl mu x is equal to 0. So these two theorems will be used when you solve the sufficient condition. So we will see the sufficient condition. Now in the proof what we do is, so you are given the equation p dx plus q dy plus r dz equal to 0. Now we need to show that the equation is integrable, provided that you have the condition x dot curl x is equal to 0. So what we have to show is, if x dot curl x is equal to 0, the equation is integrable. Now the technique of proof what we use is, later on you will use the same technique in solving the integral equation. So what we do is, we take here z as a constant. For z ആദ്യം constant ആയിട്ട് എടുക്കുക. So using that we will construct and then find a solution to your integral equation. So we can conclude that your equation has a solution, so that becomes integrable. Okay, so consider z to be a constant. If z constant aanengil dz will be equal to 0. So your equation will reduce to p dx plus q dy equal to 0. This is a Pfaffian differential equation in two variables. So such an equation will be always integrable. So therefore it will possess an integrating factor, and let me take mu to be the integrating factor. So when I take mu p dx plus mu q dy equal to 0, that will be integrable. So mu p will be equal to some dou u by dou x, and mu q will be equal to some dou u by dou y. So this happens because every Pfaffian differential equation possesses an integrating factor. Now I am replacing p and q in the original equation. So equation 1 is p dx plus q dy plus r dz equal to 0. അതിൻ്റെ അകത്ത് പിയും ക്യൂവും റീപ്ലേസ് ചെയ്യുക. So p will be 1 by mu dou u by dou x into dx, then 1 by mu dou u by dou y into dy plus r dz equal to 0. Now I am going to add and subtract the term dou u by dou z into dz. So I am adding and subtracting this particular term. So if you look at the first three terms, they will be the form of differential. So this is equal to du. Now remaining you have r mu minus dou u by dou z into dz. So let me call it as k. So you will get du plus k dz equal to 0. Now we are given that x dot curl x is equal to 0. So that is our assumption. X dot curl x equal to 0 ആണ്. By the theorem you have seen previously, x dot curl x equal to 0 ആണെങ്കിൽ mu x dot curl mu x 0 ആയിരിക്കും. Now I'll calculate what is mu x dot curl mu x. So this is the value of mu x, mu p, mu q, mu r. Now mu r is equal to k plus dou u by dou z. Now this can be written as gradient of u. So here you have ux, uy, uz, which is the components of gradient of u. So you will get gradient of u plus the vector 0, 0, k. Now take curl mu x. The curl of gradient will be 0. So when you take curl of mu x, that will reduce to curl of 0, 0, k. So I have calculated here curl of 0, 0, k. So we are going to get I dou k by dou y minus j dou k by dou x. So that's what we are going to get. So when you calculate mu x dot curl mu x, that will be equal to this. So this is the value of mu x and curl 0, 0, k. So which you get as dou u by dou x into dou k by dou y minus dou u by dou y into dou k by dou x. Now this particular sum is dou of uk by dou of xy, which you have seen in the first theorem. Our determinant the formula dou of uv by dou of xy. So since x dot curl x is equal to 0, so mu x dot curl mu x is 0 ആയിരിക്കും. mu x dot curl mu x is 0 ആണെങ്കിൽ this final term will also be 0 since both are equivalent. So ഇത് 0 ആണ്. So therefore by the first theorem, so there will be a functional relationship between u and k which is independent of x and y. So that's the result you get from the theorem. So you can form a relation connecting k and u which is independent of x and y. Now but since z is a constant, z can be also involved in that relation, but it is independent of x and y. So what happens is you can express k as a function of u and z. So k becomes a function of u and z. Now previously we have got here du plus k dz equal to 0. So du plus k dz equal to 0 can be expressed as the equation du by dz plus k equal to 0. So what you are getting is du by dz plus k of uz equal to 0, which is a first order ordinary differential equation. So the solution exists and solution will be of the form some phi of uz equal to c. Now if you replace u will be a function of x, y and z. So when you replace for u in terms of x, y, z, so you will get a solution for the equation du by dz plus k u of z equal to 0. Now you can see that du by dz plus k of uz, this is actually the original equation, p dx plus q dy plus r dz equal to 0. So we can conclude that the equation is integrable. So therefore if x dot curl x is equal to 0, the equation will be integrable. So what we have done here is we have started with z as a constant. അപ്പോൾ ഒരു two variable equation ആയിട്ട് മാറും, and you are treating z as a constant and then you are solving for the equation in two variables. So this technique can be used for solving the Fabian differential equation. So we will see that in the coming lecture. Okay, so that's all for today. Thank you.